There's the record button. Okay, yes. So now we're recording, and so you kind of have a little bit of information about Megan Fork, who is wrapping up her PhD at Duke right now. And so this is Mason and Sydney and Gus. Gus is in California. So
I'm in Seattle, actually.
So sorry, Gus. Yes. University Prep School in Seattle. We have 4 students in California. So.
Oh, yeah.
A lot of West Coasters. But anyway, so I was going to ask you to just start off by talking to us a little bit about your career and how, your education, when and how you decided on working with water.
Yeah. So, okay. So I can tell you a little bit about what I do kind of on a day-to-day basis, and then I can give you the arc of how I got here, if that works for you guys. I would bill myself as an ecologist, a freshwater ecologist. So the work that I do, I ask questions and then try to find answers to them. And the tools that I use to do that are basically field work and data analysis. So on any given week, my days can look like going out into the field and setting up sensors or collecting water samples, hiking around carrying batteries and stuff like that. Or it can be a lot of sitting in front of the computer and writing code and making figures. It can be a lot of writing papers and stuff like that. So there's a lot of the currency for a scientist is written word, and so that's how we're evaluated, and that's how we communicate, which is the most important part of our job, right? So we do a lot. There's a lot of writing, and it's a specific kind of writing, but it's still the same rules as any other writing, really. And yeah, so that's sort of what I do. Specifically, the questions that I'm asking right now are about streams and rivers in cities. So it means that my field work is gross because I'm doing a lot of climbing around in streams that are filled with trash and possums. But
as in dead possums?
Occasionally, yeah. Or snapping turtles, stuff like that. But it's pretty satisfying in that I get to ask a bunch of questions that are new, and so it's cool because I get to be on the cutting edge. It's really fun. Also, you guys should stop me anytime if you have a question, because I could keep talking forever probably. So
tell us more about how you, so that's a nice kind of snapshot of where you are. How'd you get there?
Yeah. So
think about them in high school. Start, and connect the dots for us.
So when I was in high school, I really liked biology and chemistry and math. And so I knew I wanted to do something science-y probably, but that's sort of all I knew going into college. And when I started college at the University of Wisconsin, I kind of thought maybe I wanted to be a pharmacist or something like that. And it was, I took a class in freshwater ecology and specifically about lakes, because there's lots of lakes in Wisconsin. And it was just really neat. It was learning about kind of all these things about lakes, how lakes are structured, and all of these things about how they interact with the land around them, and what we do to the land affects how the lake works. And I was just pretty smitten with that, so I ended up majoring in zoology, which was kind of where the freshwater ecology program was housed. I majored in zoology, conservation biology, and then I couldn't give up my theater major either, so I majored in that as well. Consequently, took 5 years to get through college, but that's okay. And when I graduated from college, I wanted to go on a big trip. So I went overseas to New Zealand and worked there for a year. I worked both in a lab doing freshwater ecology and on some farms. And then when I came back after a year there, I got another job working in a lab at a university, so the same sort of thing, which after a year of doing that, I rolled over into grad school. So this was in South Florida in Miami. So I did a master's degree there, and then from there came here and started a PhD at Duke. So it was it was a pretty idiosyncratic path. I didn't really have it planned out from the beginning or anything like that. It was, I was just really lucky that opportunities came around at the right time. And probably you hear this all the time, but it was a lot of like building a network and talking to people who did things that I thought were neat and asking them what I should do next.
Very good.
Yeah.
So there are lots of things that we could talk about. And you all get sort of first dibs on asking questions. And hey, we have Isaac with us. Hi, Isaac. Glad you could make it. Can you hear us? Isaac? Gus, can you hear us?
Yeah, I can hear you guys.
There we go. Good. So Isaac, I don't know if your screen is on, so let me just do a chat. Can you hear? Okay. Well, that's a good thing. We can't hear you right now. So I suspect there's a mute button. And it's not, I don't have you muted. So it might be on your end, but if you want to contribute and we can't hear you, just use that chat window. Okay? All right. So anybody have something you particularly want Megan to talk about, a question that pops into your mind, or you want me to keep going?
I would love to hear about like maybe your opinions on some of the hurricanes and like climate change and some of the more water issues that are happening right now.
Sure. So that is like, so I'm sure you guys know, like one of the things predicted with climate change is kind of changes in the intensity of precipitation. And so as a person that studies water in cities specifically, that's a thing that as kind of in this overlap between that kind of particular element of global change and the fact that we're dealing with a lot of failing infrastructure in cities, like specifically like how stormwater is managed. That's a thing we're going to have to really think about a lot. And dams as well, like all sorts of things we're seeing, like with all of these storms, like dam failures and like having to worry about them a lot more, and infrastructure. So I guess my perspective is like, unfortunately, I don't have like recommendations for what we can do except for put resources into dealing with those problems. You know what I mean? Like, I feel like that's, it's a thing we're going to have to increasingly deal with. And we're kind of at this place where we can, because we're going to have to replace the infrastructure, we can do it in a different way. So we're kind of, it's kind of an opportunity because we're sort of right now locked into the way that we thought about managing how stormwater moves around back when the cities were built. So back in, you know, the 50s to 70s particularly are kind of the paradigm that we're working with. And now we have a bunch of new ways that we think about managing stormwater. Like specifically, one of the things that happens when you pave a city is all this water that used to infiltrate into the ground now runs over the top of the ground because it there's pavement. And so one of the things that we think about now as we're thinking about how to manage stormwater is kind of making those surfaces more permeable, or finding ways to let water get back into the aquifer and into the groundwater, which kind of solves a bunch of problems at once. But one of the things that is most relevant to what I think about is it sort of makes that pulse of stormwater that comes through shallower and spreads it out over a longer time, so it's not quite as destructive right when it hits, if that makes sense.
So permeable surfaces and cities seem kind of contradictory to me. I mean, the whole city experience is about cars, pavement, sidewalks, buildings. The more dense the city, the less permeable surfaces there can be. How can a city change that?
Well, so you use the word dense, and that's one of the things that we think about is if we can build more densely instead of having everyone live in a single family home connected by a bunch of roads. By increasing density in one place, we kind of necessarily decrease density elsewhere. So that sort of on a broad scale, we can then like kind of decrease the whole footprint in that way. But also there's ways that we can not just change the way that the water moves through those impervious surfaces, so we can add little, like, it's sort of, we distribute small areas where water can get back into the ground instead of routing all of the water into gutters and pipes. We can add small curb cuts with small rain gardens. People can put rain gardens on their property. And by putting a bunch of small projects around, we can get some of that water that would otherwise all hit a stream or an impoundment at once, and we can kind of make it go in there in parcels instead.
Wow.
So.
Other thoughts?
So before you kind of got into what you are doing now, what was kind of the, I guess, like the path of jobs that you had before, or like internships or?
Yeah, so the jobs that I had before, like I worked in a lab when I was in college, just as like a work study student. And it was one that was like posted on the college job board. So that job was not in water. That was looking at doing forest ecology. And so the actual day-to-day part of the job was counting tree rings under a microscope and drawing a little pencil dot every 10 tree rings. And this was before computers could do that. Now computers can do that, turns out. But that was the kind of the context of that project was looking at how bark beetles and fire interact in forests in the West. So our field work was all in Wyoming for that project. And then after I finished college, I worked in a lab in the South Island of New Zealand. And so that was looking at how the change from, so they traditionally, most of the agriculture around that area was sheep farming, and they've switched to dairy in a lot of places, which is a lot more intensive use of the land. And so we were looking at how that how that affects the streams in that area. And so that I did a lot of field work for that and kind of just collecting water and setting up experiments and stuff like that. But really the kind of intellectual work was all done by the graduate students and the managers of the lab.
How did you get that job?
So that was one of the professors that had given a guest lecture in one of my college classes. I sent her an email that was like, hey, I remember you saying you worked in New Zealand. I want to go there. Can you tell me tell me any of the names of scientists you worked with? And she gave me a list of basically everyone in the country that did any sort of freshwater ecology, which New Zealand is a small country. It was a pretty short list. And I cold emailed all of those people, and one of them just happened to have gotten a grant and needed technicians to come and work. So they'd hired like me and one other person, and I was just lucky that the timing worked out on that. And then it was sort of the same thing when I came back to the US. The job that I had after that was I found a job posting for a technician in a lab and applied for it and interviewed and got that job. And then that was the last time I had a real job. So I've been a student for like 8 years now.
You've had really very geographic experience.
Yes.
With, Wisconsin, Miami, did you say?
Mm-hmm.
North Carolina,
New Zealand.
New Zealand.
Yep. That pretty much hits the highlights. So, yeah.
North Sweden in the offing.
Yeah. Right.
Wow.
Yes. Yeah. Yeah. So I'm starting a job in January in northern Sweden after this.
Wow.
So, but yeah, I mean, a lot of it, for all of the jobs that I've had, it's been kind of having an idea that I wanted to do something and then asking people what the resources I needed, whether it was a list of people's names and emails or what job posting boards should I be looking at if I'm interested in this and stuff like that. So it's a lot of like, for me, it was a lot of like asking professors and kind of, I now know that it was building a network, but I didn't realize it at that point. So.
Who else has something on your mind?
I guess also testing, does this audio work?
It does. Yay, we
It
hear.
does? Good. Sorry, I guess I think my setup was a little weird. I guess I'm wondering, now that you've kind of tried a series of different things, if you could, like, are there certain classes or topics or something that you would point to as being most important in the work you've been doing?
So, yeah, absolutely, yeah. For the work that things that I have done that I thought were really important was, it was very helpful for me to have done like math and chemistry in high school. So I did, those were like really important, setting me up for college classes, and things that I did in college, or maybe I'll start with things that I wish in retrospect I had done in college. A lot of the work I do now is kind of stuff that I think I would have learned in kind of computer programming, statistics, and engineering. And I have had to teach myself a lot of that, which has been really fun. But I think I would be, especially computer programming and kind of data science, that is where my field at least is going, and kind of, especially with water quality stuff, it's all going to be, I predict, we can talk in 20 years and we can see if this has come true or not, but like, it's going to be all just remote sensors that are deployed in places and beam data back, and it's going to be very little like collecting water samples, I think, and it's going to be a lot of managing data and doing data science. And so the stuff that people would need to know for that is like computer programming and statistics. And it is, yeah, that's increasingly become a part of my life for sure. But also things that I did in college that were helpful. I sort of on a whim took the took these ecology classes, I kind of thought it was interesting, and that sort of set me on this whole path. So I think especially if something sounds a little interesting and the stakes are relatively low, it's worth doing because you might find something that you really care about.
Can we also observe that in somewhere in your educational path, up to now, that you learned how to learn and were able to then learn what you found out you needed to know that you didn't know to study when you were in college? I mean, like that learning how to learn process sort of set you up, even though your interest changed and the world changed. In the meantime, it's kind of impossible to know really what any of us is going to need to know 20 years down the road. But if you get good at learning by taking courses and paying attention and doing things, you're able to work out even really big and difficult things like computer programming and data analysis.
And a lot of it is proficient Googling, and a lot of it is figuring out who knows that thing that you can ask for help. So, but kind of along that topic, but not that different. Like I know for me, one of the hardest things about going into science as a professional after having been, well, I guess I'm still a student, but like having been a classes taking student for a long time and transitioning to being like a working scientist, was feeling stupid all the time. And maybe I can send you this paper, but there's like a short paper that I read early in graduate school that was basically just like, if you want to be a scientist, you have to get used to feeling stupid all the time. You've probably felt smart a lot of your life. And if you're doing good science, you're going to feel stupid because you don't know the answer. And if you knew the answer going in, the science is boring. So it's sort of, that transition was really difficult for me, as to kind of like realize how many things I didn't know and learn to be okay with that and learn to make mistakes, because trying to learn new things, you make a lot of mistakes and you look back and you're like, oh man, if I only knew, I would have been able to do that in 10% of the time. And you just have to be able to like recognize that is how it's always going to go, I think.
I have a question for you. So do you have any like really good stories or like anything that you learned a lot from how the environment affected water and through your studies and observations, I guess?
One of the things that I'm thinking about a lot right now is sort of what stormwater does when it goes into a lake. So one of the projects that I did was at Oak Ridge National Lab, which is in eastern Tennessee. And I remember this is sort of like, I guess this isn't going to be an answer. It's going to be more of like, this is a question that I was really excited to have. But like all of my career so far, I think about how stormwater gets into rivers. And basically it's like, you have this big pulse of water, it gets into the river, and then it's gone because it's always flowing downstream. And when in eastern Tennessee, there's all of these dams and all of these like impounded lakes. And I remember thinking about it during a storm. I was driving to the university and seeing all of this like muddy stormwater from the city kind of going, and seeing these plumes of it go into the lake. And that was the first time I thought about the fact that all of this water, like, it sounds stupid, but like all of this water flows somewhere. And like all of these big pulses of urban runoff that are carrying all of this metal pollution and all of this like pharmaceutical pollution and all of that, all of these nutrients are going into a lake. And then they do something to the lake, but then we don't think about them that much after that. So trying to think about like what's actually happening to that water as it transitions from being in the stream and into being in the lake was probably the most recent really exciting thing that happened to me. But I don't have like an answer as to what I've learned because it's like a thing that I'm excited to learn about.
Yeah.
I'm sure I could come up with one.
That was a good story. Thank you. That was great.
Yeah.
Megan, when you think about this change that you foresee with the sensors and spending relatively little time out in the field as a scientist and doing a lot more with data and modeling and whatever, does that make you happy? Or does that make you a little bit sad? Maybe you won't miss tramping around in streams where there are dead dolphins and things like that. Or
I mean,
will you?
it makes me happy because I feel like our opportunity to learn is greater. So one of the most expensive or like most valuable resources in doing science is like the scientist's time or a person's time. And so if we have this technology that lets us use our time for the data analysis instead of carrying a heavy pack out to get 2 water samples and then come back, the amount that we can learn about how the world works is that much bigger. And so I'm excited about that. And I'm also very happy to take a big heavy pack and tramp around outside on my leisure time instead of for work.
So for work, are you spending most of the time on the water, like canoeing or using boats or along the shore or what?
So all of those things. So I've done, for the work that I do, a lot of it is in small streams that are like no deeper than waist deep. So a lot of that is like walking out along a trail and putting on waders or boots and collecting water samples that way. Or like we have some sensors and some equipment that we deploy, and so it'll be going out and checking on those and replacing batteries and doing maintenance and stuff. So that is like a lot, mostly like hiking and some like waist deep water kind of stuff. And then I've also done a lot by canoe and a little bit by like John boat and stuff like that. So it's sort of, it's environment dependent, more or less.
We have time for maybe one more question. Anybody have something else on your mind?
I have one question. Is like, given your kind of experience and all the different things you've learned, if there was kind of one piece of advice or one thing to be aware of that you could tell to people, maybe something that most people just don't think about or aren't conscious of that could make a difference, if that makes sense, what would that be to tell to people?
Yeah, so I think from the pithiest way that I've heard this put is that is everyone lives downstream. So just like when you think about kind of anything you're putting, like any water related thing, where you live is part of a watershed, and there are people that live upstream of you and there are people that live downstream of you. So everything you're doing to the water that is around you is affecting someone. So think about that. Like one of the main things that I study in my work is the fact that roof gutters are parts of the stream network when it starts raining. So like whether or not you clean out your roof gutters affects what the chemistry of the stream water looks like. And if you dump stuff on the side of the road or whatever, or like there are leaves kind of in the side of the road, that's all part of the stream network when it rains. And so everything we do kind of affects the water chemistry. And so we should think about that.
Well, thank you very much, Megan. And thank you, students, for your excellent questions. Zoom is about to kick us off because I have a 40-minute max and some of you have to go anyway. So good work, and you can say goodbye and I'll see you soon.
Thank you.
Thank you.